Welcome back to Boiler Wild. My name is Eric Johnson, and on this podcast, talk about boiler industry topics as well as personal development. I have a interesting one for you today. I'm going to be talking about boilers, condensing boilers, and the efficiency and how efficiency is calculated on a boiler and why a condensing boiler may be advertised as more efficient than other condensing boilers. It is a game that manufacturers play, but we need to look into the data and determine what is correct. So first of all, a lot of the efficiency of boilers, a lot of that is marketing. And as long as you understand, and most people do, but as long as you understand that we are up against physics and no manufacturer has physics figured out better than another manufacturer. If a manufacturer says, hey, our boiler is 99% efficiency, they don't have some deep level knowledge of physics, of how physics works versus another manufacturer. They have just designed their boiler to be able to have a different water temperature than another boiler that may only have a 97% efficiency. But a boiler with a 99% efficiency that is advertised at that rarely will run at 99% efficiency. And that's what I want to talk about today. So, if you are new to the condensing boiler market, a condensing boiler is something that is kind of new to the boiler industry. I wouldn't say it's new, but it's within the last 20 to 30 years, condensing boilers have reached the market and become popular, and that is due to saving energy and the higher energy prices and a lot of government rebates for reducing emissions. And we want to make the world a cleaner, better place. So manufacturers started coming out with a condensing boiler, and a condensing boiler is different than a non-condensing hydronic boiler in the fact of how the heat exchanger is built. Both boilers will condense. So if you operate a non-condensing hydronic boiler wrong enough, it will condense. And over time, if you keep operating it at that state, you will ruin the heat exchanger because it is not meant to condense. So condensing is water vapor coming out of the air and turning back into liquid onto the heat exchanger. And a product of combustion is water vapor. So when you pass that water vapor over a cooler surface, you can condense it out of the air and recover that latent heat, and you increase the efficiency. I hope I explained that correctly. That's the basics of it. Condensing is keeping latent energy and some sensible energy in the boiler. There's two types of heat. You have sensible heat and you have latent heat. Sensible heat is a temperature rise. So if you have 80 degrees and then you raise the temperature of water to 90 degrees, that's sensible heat that you're adding to the water. Latent heat happens on a change of phase. So when water goes to a gas, you add latent heat. And since we know that energy is neither created or destroyed, when you take water that's a gas, water vapor, and you turn it back to a liquid, you are now recovering that energy. So, number one, make sure if you have a non-condensing boiler, which would be a carbon steel boiler, or most times a cast iron boiler. There is one cast iron boiler condensing out there. We'll talk about that briefly, but you will know if you have a carbon steel boiler that you have a non-condensing boiler, and you need to keep your return water temperature above 130, 140 degrees. And it depends on the dew point, but that is around where the condensing happens, 130, 140. Typically, a normal hydronic system is going to run at 180 degree set point with a 20 degree delta. So you're going to have a 160 degree return water temp. That is typically what the average hydronic system was designed for. But you can now with these newer condensing boilers, you can now run lower water temperatures, which allows you to be more efficient. And as you get below the dew point, and when your return water temperature gets below 140 or 130, somewhere around there, you will start condensing, and the flue gas will condense on your heat exchanger. And that is why condensing boilers have condensate lines coming out the back of the heat exchanger with condensate traps and condensate neutralizers. Because condensate, when it's made, is acidic. And that's just water. But the latent heat is where you get your efficiency. That is where you are gaining that efficiency status of the boiler, whether that's 92% all the way up to 99%. So what is the difference between a boiler that is advertised at 94% efficiency and 99% efficiency? It just comes down to what the boiler manufacturer has designed for the heat exchanger for the boiler on what they can handle for water temperatures. That's it. I'm not going to go into that further because there's a lot of more physics and marketing nonsense with it, but it's not important. But different condensing boiler manufacturers will use different heat exchanger materials and designs that allow them to create a boiler that can handle different water temperatures. So the boiler that is 99% efficient, why doesn't everybody just install a boiler that's 99% efficient? Well, I'll tell you this. There's an efficiency curve. Every manufacturer has an efficiency curve, and the efficiency curve changes with return water temperature and firing rate of the boiler. So you'll have different curves on the efficiency curve chart depending on the firing rate and depending on the water temperature. So your water return temperature is on your x-axis, and the one I'm looking at, this is from Lochinvar. We have 60 degree water to 170 degree water on the right, and then our efficiency is 85% on the y-axis to 100%. We have firing rates of 5, 50, and 100%. So we have 3 data plots on this graph. You can find this graph on Lochinvar's website if you want to look at it, but every manufacturer has a similar graph. And it essentially shows you that a boiler that is 99% efficient is 99% efficient at 5% firing rate when the return water temperature is 73 degrees. So how many hydronic heating systems do you know with a return water temperature that's 73 degrees? I don't think I've seen any. They're out there, but very, very, very rare. And normally that's a special application. You cannot do much heating with 73 degree water. To get to, let's go all the way to the right hand side. So at the same firing rate, so at 5% firing rate, at 160-degree return water temperature, the boiler is now 88% efficient. So we changed the water temperature, and our boiler that was 99% efficient is now dropped at 11% efficiency, and now we are no longer condensing, and we're not getting the efficiency that we paid for. A return water temperature of 160 degrees, like I said earlier, is typical of older hydronic systems that have a 20-degree delta. So you would have a set point, so an outlet temperature of 180 degrees. With condensing systems, you typically, depending on how the system's piped, whether it's primary variable or primary secondary, you will have a wider delta. So your return water temperatures will be lower and your supply water temperatures will be, sorry, I'm saying that wrong. The delta across the boiler, so temperature difference between the return water temps and the supply water temps, can be greater. I've seen boilers up to, I think, rated at 100-degree delta, which is pretty extreme. And that's just due to the thermal stress of the heat exchanger and what the manufacturer has calculated that it can handle and tested. So let's do the 100% firing rate efficiency. So same boiler at 100% firing rate at 73-degree water temp is 97% efficient. And at 160-degree water temperature, it is 87.5% efficient. So you can see there, we have the same drop. We're not quite 99% efficient. We're at 97, but we dropped down to 87.5 at 100% firing rate. And then the 50% firing rate is about in between the two curves. But that is true for all manufacturers. There's no manufacturer out there that has a 99% efficient boiler that is 99% efficient at all water temperatures. That would break efficiency, as you now know, efficiency of condensing water temp. As efficiency of condensing boilers is based off of where that efficiency increase is coming from, is the ability to recover some sensible, but it's the latent heat energy before it goes up the stack. Now, for a condensing boiler, every manufacturer will tell you this, and especially the warranty department. Everybody may look at the product literature and look at all the efficiency ratings and all the fancy stuff, but every manufacturer will tell you a boiler is only as good as its install, and many boilers are installed and doomed from day one. I can guarantee every single manufacturer's warranty department has gotten parts back that have failed prematurely, and they're due to poor installation. I have seen myself some very poor installations of condensing boilers. And when you have a boiler that isn't just half-inch thick carbon steel and just very overbuilt, and you start operating it at limits of what metal can handle, you start running into problems. And then what happens is the boiler breaks prematurely. Contractor or customer comes in, this thing's junk, never should have bought it. And then normally another contractor comes in that reps another brand. Yeah, it's junk. And puts their own brand in and calls it the best thing ever. Well, they're all the same. So if you don't have the correct installation per the manufacturer's manual and it's not started up correctly, that boiler is doomed. And whoever started up the boiler did not do their job correctly. And the install and how the boiler is operated and sized will be your biggest efficiency gain or loss, and it's not going to really be your water temperature. So typically condensing boilers I've seen run They'll have return water temperatures of 100 degrees and supply water temps of 140, 150. And that can also change the outdoor air reset. Outdoor air reset is when you adjust the set point depending on the temperature outdoors. So when it's 0 degrees outdoors, you're going to have the hottest set point. And when it's, say, like springtime and it's, 65 degrees outdoors, you're going to have a lower set point. And that will help the boilers stay running longer, stop cycling, and keep the heat output of the boiler system more closely match the load of the building, because the heat load of the building for a building that is sitting in a 0 degree temperature day is a lot greater than the heat load that is 65. And if you run your boilers at a warmer water set point, the boiler will come on, it will quickly heat up, and then the boiler will turn off, and your valves for your loads or whatever may barely open, and it'll cause the boiler to cycle, and you'll end up wasting a lot of energy. Cycling boilers creates a lot of efficiency loss. I could talk about this for hours, but this goes on. There's all kinds of things that you can do to increase the efficiency of your hydronic system. And it very, very rarely comes down to what the marketed efficiency of your boiler is. Your efficiency of your hydronic system is really going to play into how well the install is and how well the engineer sized the system, sized the boiler, and what's your water flow like, and what your water temperatures are. Now you may be wondering, well, why can't we run 130 degree water in a building where we just installed condensing boilers and the set point was normally 180? So if you have a building that maybe you retrofitted the boilers and you changed out some non-condensing boilers into condensing, and you told the customer, oh, we're going to save all this money, the boilers are efficient, we can lower the water temperature. That may be true on spring days, like I said, outdoor air reset. But when the outdoor air temperature is at 0 degrees or design day, the set point of the system is going to have to be 180 degrees, as that's what your loads are sized at. So in order to use lower water temperature to heat the same building, you need to increase the size of your coils. And normally that's done, you'll have coils in air handlers or VAVs, but you'll increase rows through your coils. So now they'll have 4-row coils, even 5-row coils, where typically if you have a 180 degree system that's old school, you may only have a 1 or 2-row coil. And that just gives the air more rows in your coil, gives the air longer time to be in contact with the coil and to heat up. That's essentially how you get the more BTUs out of cooler water. I'm trying to keep this not physics. I'm probably butchering the explanation of this, but as long as you understand that a condensing boiler does not always run at the efficiency that is marketed at. This Lochinvar efficiency chart at 100% firing rate is the boiler is only 97% efficient. When it's at 73 degrees return water temperature, so that would make our supply water temperature maybe 110, 120, which is pretty low depending on the application. It all is up to the engineer. Bigger coils that can handle lower water temperatures and still heat the space cost more money. So it's a balance of what the building owner wants to pay. And there's a balance to everything in engineering. So getting back to the efficiency, just understand, and it's important to understand that the rated product efficiency of the manufacturer, that is the max efficiency that that product can handle or be at, but that is rarely what the boiler is going to run at. Number two, if you run a condensing boiler in non-condensing water temperatures, you are not saving any money. If your return water temperature is 160 degrees and your supply water temperature is 180 degrees and you are not condensing and you are now not taking advantage of any of the features that you paid for in a condensing boiler. So you might as well have bought a non-condensing boiler. So if you never plan on running condensing water temperatures, there's no reason to buy a condensing boiler. Condensing boilers will cost more money and they are more maintenance. Number three, there's no manufacturer out there that has physics figured out better than another manufacturer. The efficiencies of condensing boilers, that comes from the sensible and latent heat recovery of the exhaust. And really what manufacturers are doing with their condensing boilers are figuring out the best heat exchanger materials that can handle the thermal stress and balancing it with cost. So everything is costs. So, a lot of people say, oh, stuff isn't built like it used to be. If manufacturers built boilers like they used to, they would be outpriced from the market. The market basically calls for low cost, high efficiency, which is very hard to do. And since manufacturers have really only been doing condensing boilers for the last 25, 30 years, it's still relatively new. And I would say it's still relatively new to a lot of engineers who you would think, would have it figured out. But there's a lot of engineering firms and individual engineers that still screw up designs for condensing water systems, and that dooms the boiler from day one. But just understand that the manufacturers are doing their best to balance cost of the boiler versus the output and efficiency and lifespan of the boiler. They are not designing boilers to last 50 years. They are also having to use different metals in order to allow the boiler to be a condensing boiler. If you use carbon steel, it would rot the boiler away. You'd have tons of rust, and the boiler would be your most efficient boiler for maybe 6 months, and then it would fail. Now, a note on that, there is a boiler out there that is advanced thermal hydronics. It's the KN boiler, and it is a condensing cast iron boiler. And now you may be saying, cast iron? I thought you couldn't condense with cast iron. Well, they have designed this boiler. Essentially, they know the cast iron will corrode, but they've done tests and they found that the cast iron corrosion is not enough to affect the lifespan of the boiler, and something else will fail in the lifespan of the boiler. So say like 20, 30 years, typically, by the time you get 20 or 30 years, the controls are outdated. The building owner wants something new. Like the boilers that are lasting 70 or 80 years, that's not a thing anymore. It could last, but typically a condensing boiler is only built for 15 to 25 years if you're lucky. The controls are going to be your biggest limiting factor. All the touchscreens and everything. That's technology is just moving so fast on that a touchscreen built today in 25 years, it probably isn't going to be supported, and you may not get parts for it. So if it breaks, you may be able to upgrade it, but the boilers are low cost enough that it may be cheaper and better to just replace the boilers. So you can get 20, 30 years if you're lucky out of a condensing boiler. But so these condensing cast iron boilers that are these KN boilers, you should look it up, are essentially built to corrode slowly. And like I said, they've calculated it, and they've been around since 2002. They have a couple different sizes of it. I'll say they don't have the larger sizes. A lot of manufacturers have come out with condensing boilers that are 10 million, 12 million BTUs. These KNs are, I think they go up to 4 million BTUs on the normal series. So 200,000 to 4 million. And on the KN series plus, which is just their ultra high efficiency cast iron boilers, it's 600,000 to 4 million BTUs. So it's going to be on the smaller end, but most condensing boilers are in the 1.5 to 2 million range. So this could still be a selection that you could look at if that is something that you were looking for. But that's condensing boilers and efficiency. Hopefully you learn something and understand it. I am, like I said, if you've listened to previous podcasts, I am trying to work on communication. Not a good talker. This is not fun for me. I hate talking. Podcasting is, I never thought in a million years I would have a podcast. And this is very, very new to me, but here we are. I am dedicated to the cause, trying to educate more people. And if you have topics or you want to be a guest or have a guest recommendation, you can email me, Eric.Johnson at boilearn.com, BOILEARN. If you have any questions and are on LinkedIn as well, make sure you're connected with me. DM me those questions. DM me, shout out the podcast. That'd be great. I am slowly but surely making episodes. I know I took a small break. I got a little busy. I'm still trying to figure out the busy and balancing the podcast. When your day job is one thing, the podcast is just another addition. But I am not complaining because I'm the one that chose to start the podcast, and I'm the one that's doing the podcast. So I have no reason to complain for something that I am choosing to do. So I'm making the best of it, hoping to get better. Hopefully you understand efficiency and why different condensing boilers are rated differently, and that the rated efficiency that ends up on the marketing brochures are not really the efficiency that the boilers can realistically run at, and they definitely will not run at that efficiency for all water temperatures. So that's all I have for today. Thank you for listening, and stay wild.